Hey everybody, how's it going? Hope you can hear me okay. All right, I am going to be talking about 3D printing today and how to do it from home. It can get very involved, but it's base level. It's not. It's very simple and very easy to do at home. And you can create and do all sorts of amazing things with 3D printing at home. There's just some things that you need to be aware of and how to maintain it. Anything you do as a creator, you are going to be needing patience. So if you sit down and do stuff and you just can't take the time to do it, then I don't know, maybe think about something else. But ultimately, there's so much satisfaction in creating stuff. Just you can make anything you want with a 3D printer. So I'm gonna go through my setup, and then I'm gonna teach you how I got into it, like why I got into it, and what to do about solving problems that you face with 3D printing. And what can it solve, and what can't it solve, that kind of stuff. So during the course of the chat or this demonstration, I am going to be doing a giveaway. The giveaway is for this, not this particular one, but the same exact print, same color and everything, of this 3D printed plant. This is my little planty 3D printer. This is a coarse resolution. It's a little bit less quality resolution than I will be printing for the giveaway. But this is the actual design. I have to attribute this. I got this off of Thingiverse. It's a website I'm going to teach you about. There's a couple of them that are pretty amazing. You can just download these objects that are pre-made for you. You slap it in a few tools, make sure it worked and sized right, and then you go to town, print it. But this is just a plant holder. As you can see, it's just a little villa. It's got some opening there. It's got a little fake swimming pool with the water coming out the bottom. So it's pretty cool, pretty cool. But that's what I'm going to be giving away. So if you win the giveaway, I will ship it to you free, no cost to you. But that's what you're going to win today. So all you have to do is in the chat, you have to ask questions. The more you ask questions, the more you're talking or whatever, the more likely you're going to be selected for the giveaway. That's the tip. And I believe you can type question mark. Let's see what it is real quick. Not question mark, but exclamation commands, I believe. Yeah, no, that's not it. Anyway, so you can join the giveaway. It tells you how to do it, and you'll gain points, and you could be picked as the winner. So the first thing I want to talk about is why I got into 3D printing. I like to create stuff anyway. That's just who I am and what I do. But I saw on an Instructables website a guy, I think it was a 14-year-old, that had created a 3D printer. And I looked at it and I thought, this is actually really simple. The only thing that I don't know how to do is code an embedded system for a 3D printer, and I realized that I didn't have to. I might have had to just change it a little bit, but I don't want to talk about doing that because that's not what I'm not. You don't have to go that route. I want to very stress. You don't need to know how to code or do anything in order to create or work with the 3D printer. It has nothing to do with that. So what you want to do is there's a couple of websites. There's lots of places where you can find a 3D printer. I happen to buy the one I'm printing with right now, off of GearBest, and it's the ANET A8, or the ANET A8 version is what I'm printing. And you're going to see a video of it in just a little bit. But anyway, so I saw this 3D printer that this kid had designed and created on Instructables.com, and I thought I could make that. So I followed the instructions. I had to have some plastic parts laser cut, and then I had to have somebody 3D print me some parts or machine these parts. But I had them 3D print me these parts. I bought a bunch of the stuff off of AliExpress.com, which is direct to market from manufacturers mostly, and you can buy them, but they take a long time to get to the United States. If you're in a different country, then you can definitely probably get them sooner, faster. It takes about a month and a half, 2 months sometimes to get parts, motors, things like that. So, but I built mine from scratch. I'm not going to recommend you do that unless you want to, unless you know how to code, unless you know how to upload embedded code onto boards, that kind of stuff. So, but that's not the normal. So you can purchase a 3D printer right off of one of these websites, and it's not that expensive. I bought mine for, I think it was $218, and they go on sale once in a while. And I was a little hesitant on the quality of the print, but I've been very, very happy and surprised at the quality of the print that comes out. It is not a industrial print. You know, you're not going to get this super perfect smooth print out of it, but there are ways to make it a lot better than and really close to it. So much though that you'd be proud to have something on your desk that you created. So it's pretty cool. So let me just so anyway, so what I had done was I followed the steps, but that printer, it had some really bad problems. First off, it was flimsy, and you have to have a very, very rigid structure when you're 3D printing, because when the nozzle is going back and forth and the bed is moving back and forth, there's vibrations, there's all sorts of stuff that is happening all at the same time. And if that nozzle isn't spitting out exactly where it needs to spit out, you're going to have like weird plastic, and it's not going to line up, and you're not going to have this nice smooth edge. And you can, so there's still some issues with my printer, and you can actually tell. If I bring this up kind of close here, you can see like there's little, it looks like there's little holes in this, so it's not like a perfectly flat. And granted, I printed this at a very low resolution, just so I could print it faster and see what it would look like, and because I wanted these plants on my desk. I built this desk from scratch, and I wanted something nice to make it look nice, and so I printed this just to see. I like it. I'm going to keep it. So that was the inherent problems with the printer that I had built. It wasn't very rigid, and so I took one of my old computers, a computer case, and you're going to see it in the video, and I gutted the printer, or I gutted the computer because it was just an old one. I took the power supply from it, mapped everything to what I needed to for power, and then I basically created the same thing but more rigid as the 3D printer. Now I spent probably, I don't know how long, maybe 4 to 6 months adjusting the code that was controlling the printer, because it was a custom printer, like built from scratch. And there are some open source basically software that you can embed into the printer that controls the printer board and that kind of stuff. But you have to know that kind of thing, and I do, and so that's where I was able to manipulate it and make it work. And sure enough, I got it to work. There were some problems with some things, and I fixed them. But it wasn't without headaches, and find out you don't have to go through that. So you can just buy an off-the-shelf printer. If you, depending on who you buy it from, if it's pre-assembled, you're going to pay more for it. If you assemble it yourself, it's going to be less. Mine, I had to assemble myself, but all the parts are there. It's a solid printer. You can add and you can customize it even more by itself. Like you can 3D print parts for itself, add those on, and it makes it even better. And I'll explain some of those enhancements that I did to the printer that I bought from just off the shelf. And from there, you can start printing anything you want. The filament that you'll be using is typically either ABS or PLA, but there's lots of different filaments out there. I print in PLA a lot. This right here is a spool of plastic, basically. This is PLA. Happens to be pink, and it comes in these little spools of thin plastic, and this is, get it right on there, this is 1.75 millimeter PLA, and it comes in 1 kilogram. You can buy it in less or more, but I typically buy 1.75 in 1 kilogram. Now this here, it doesn't quite, you can't really tell the difference on the camera, but this is ABS. ABS is a little bit more rigid at certain things, but it is more of a harder plastic. It has a higher temperature of melting. So the idea of a printer is this stuff is pushed through a hot nozzle. That's it, little by little, at exact points, and it melts to itself, and then you build stuff layer by layer, up and up, until you finish the product. And you'll see the printer working, and how it actually works and builds, and the insides of models and stuff like that. I'm also going to talk a little bit about the modeling itself. So when you're looking at 3D printers, that is one of the biggest things that I want to just stress is look at printers that, one, have a good rating. People have bought it, they like it. You're gonna, it's hard. Sometimes you get bad reviews on printers that are good, but there are some brands that if you're paying for a brand and you don't care the price, then I would go with like a MakerBot printer or some of those ones that are pre-assembled. If you want to print in ABS, anything other than PLA, something that requires a higher temperature to print with, ABS, when it cools, it warps. And so if you're printing on a flat bed and you don't have the environment enclosed and a heated temperature of that environment, that model is going to come off of the print bed and warp up, and then you're going to get this weird model, and it's just not going to look right. It's wrong. You don't want it. You don't want that. So ABS is a little bit harder to print in. If you're printing small objects as ABS, those objects aren't going to melt in your car. But if you print them, say like you're printing a phone holder for your car, you want to print that in ABS because it's not going to typically melt or warp in the temperatures of a car in the summertime. But PLA, it is susceptible to that printing or that warping. So I would consider those like what you're going to be printing. But to starting out, I would just stick with PLA. It's the easiest. It's actually a corn-based material, and so you can print things that have to do with food. You can print spoons and bowls and all sorts of stuff with PLA. ABS, I wouldn't print spoons and bowls and stuff like that you're going to be touching your food with, because that is a chemical plastic that is not biodegradable. I don't think it's biodegradable. It's not biodegradable. That's the stuff that, you buy something and typically it's ABS, and it's the way that's created is it's injected. It's forced into a mold, and then that's why you get these really, really nice smooth edges, because the mold itself is perfectly smooth and created to have those on like plastic toys or plastic parts or whatever it might be. ABS is stronger. It's going to hold a lot more strength than PLA, but for all intents and purposes, PLA is going to be a really good quality material for you to just start printing with. It's very versatile. You don't need to have even a heated bed. I'm going to talk about all that stuff as well. And then you can also print molds out of your 3D print, and then use like resin or other things to create stuff as well. So let's take a look at some of the. Let me just show you the video of my print right now. So what's going on? This is going on right now. This is not a live. It's not live. I recorded this earlier, but this object is still being printed. So let's take a look, and I'm going to switch to this one here. Let's just go to NoCam here. So this is the 3D printer. This is printing a pot holder, and it is the second one. And so I've got these two other pots. But this is, let me pause it for a second. So if you can see that the spool is up on the top and it's coming down. I have jimmy rigged all sorts of stuff here with clamps in order to get this here, but a lot of 3D printers will come with holders, and but I've customized this enough that I wanted it on separately on its own, just kind of up above instead of on the ground near it, because I wanted it to come the spool to come in from the top. Now you'll always have some sort of display on 3D printers. You can see that this one, if I go a little bit further here, this one shows me the nozzle temperature, and you can see there's a 1 on the nozzle. The nozzle, this one is heated at 223, and that's because this filament, it is better about, it prints better at 223 as opposed to 220. PLA prints, and this is Celsius, not Fahrenheit. So it's really, for imperial people, it's about 400 and something degrees. So you don't want to touch that with your finger. It's gonna burn you pretty bad. PLA typically prints well between 210 to 220, and it's like you get recommendations on the actual spool of filament, and like the one that if I show you this particular one here, this one, the pink one that I have, its print temperature is recommended from 215 to 230. So, you know, if I, and you kind of have to play with it a little bit. You do a test print with the new filament that you have, and a spool like that only costs about $15 to $30 on Amazon or some other places. But and there's different qualities of filament. But you'll get to know what filament you like best and what works best on your machine. And the filament lasts a long time. So it's not like you're going to go through, you know, it's not going to cost you $15 a print. It's like pennies per print in reality. And a lot of your 3D print programs will go through, and you can calculate how much a print costs. So if you're going to print for something for someone and you want them to pay for it, you can actually estimate how much it's going to cost you, and then you got to estimate time in and all that kind of stuff too. So this is the bed print. Mine is messed up right now, and so the bed is not being heated. There's just a short in it, but I'm going to fix it. It's not too big of a deal. But some of those things you'll have to get to know and you'll understand, but they're not really hard to understand. It's a little bit of electronics, but not much. You know, if you plug in stuff, you can kind of see and understand what's going on. So this is the display. There's lots of things you can do with the display. Now I want to just mention as well, so if I go back a little bit, so this you can actually, with this knob, you turn it and there's a whole slew of things. There's an SD card built into this one. You can upload your model to the SD card, slap it in the machine, print it directly from there. I don't do that because I want to manage it using my desktop machine, my computer, and so I use what's called an OctoPi. It's a Raspberry Pi device that I've loaded an operating system on called OctoPi, and it controls this machine, and I have a web interface I can look at, and as a matter of fact, I'll show you that right now just so you can kind of get an idea of what that actually is, and I'll have it load, and while loads, I'll continue to show the display here. So then you've got your nozzle. This is your the nozzle is at the bottom of this, and these wires are the wires that heat up your basically little box that the filament goes through. So it gets forced through this into the end. And now this is a Bowden. This is not a Bowden. I forget what it's called, but this is a direct drive system where the filament is open, exposed. It's whatever. It doesn't matter. And when it comes into the there's a motor with some gears, and those gears go like this around the filament, and the filament is forced into that hot nozzle, and that way it keeps forcing as much as it needs to into the hot nozzle, and it forces a tiny little bit out on the other side. And you can get different sizes of nozzles depending on how high resolution you want to print. I will typically, what I use right now is a 0.4 millimeter nozzle. You can go lower, you can go bigger, depends on what granularity you're looking for your printing. If you go bigger print, obviously you can print faster because it's putting out more stuff, and it doesn't require as tiny or thin of layers. And the system will calculate that for you. You don't have to worry about all that stuff. It's smart enough to know how to do that for you. This is a direct drive. There's another type that's Bowden printer, Bowden type, and I'll show you that. That's the other type of printer that I built from scratch, and you'll see that in just a little bit here. Okay, so this is right here. This is the high temperature nozzle. It has the white wires are the temperature reader, and the red ones are the actual heater wires, and it controls that. It knows its own temperature, that kind of stuff. Okay, but what I wanted to show you is, so this is Octopi. This is basically, it shows you the temperature. I can see the temperature here. It tells me it kind of fluctuates just a tiny bit, and the bed temperature down here. Over on the left-hand side, you end up with, what's the print time left. I've been printing this for 3 days, and there's 9.5 hours left on this one. So this has been a very high resolution print that I'm working on, which is this right here. It's been printing for 3 days. And down here, I can upload a ton of files because I think I've got a 32 gig SD card in my Octopi. I can upload all these files that I could print, and then I have just this library of files I can print. Will it fill up eventually? Yes. So I go through and I purge some of the files once in a while that I know I don't need, or test prints and that kind of stuff. But you upload them, you select it, and it loads it up here, and then you hit print. That's it. That's basically it. That's how it works. I have set mine up so that under the control, I have a camera viewing the print. So this is live right now. This is actually the print that is happening for the that I'm showing you in this video here. This is, so yesterday it was like this. Today it's this much higher. It's printing the very top portion of it, and it will be done in 9.5 hours. But the resolution is much higher than the resolution I printed the other one. So you've got control here. You can actually look at the G code, which is layer by layer, and I'll show you that in a different program, which is how I use the system. And then there's some other things that you can do to help. But this is, I can access this anywhere on my network from any computer in my network. You can expose this so that it is outside of your network, and if you want, there's apps that you can install on your phone that will help you control and view your printer from remotely anywhere you want in the world. I've done that, but there's security issues and stuff like that. I don't want to be hacked and stuff. So that's the only thing about that. But you can do all sorts of stuff with Octopi. It's really cool. Okay, so I'm going to minimize that, and we'll get back to this to show you what's going on here. There are typically a couple of fans that are going to happen near the nozzle. This fan actually keeps the filament hot, cool as it's being forced into this metal piece. It's kind of looks like this up here, but it has a hole in it, and it just goes directly into that box. There's fins all around it, and that this fan will cool that so it doesn't melt prematurely before it goes into the box. Because if imagine a line of something melting too early, and then you have something hard, you just get this bubbly, and it might come out, and so you don't want that to be melted at all throughout the entire pipe. It can be a little bit melted, it can be warm, that's fine, but you don't want it to start to break down, and so it gets forced as a solid into the box, and then it like almost instantly melts very quickly, starts to melt, and that pressure of continuous hard nozzle or hard filament being pushed into that melted area is what forces that melted stuff out the nozzle on the bottom. And obviously it's thicker coming in than it is out, and so you don't actually put that much in, it doesn't force it, but the motors are designed so that they will force it as it wants to. And that's some of the issues that I was facing with one other printer I had, is it wasn't strong enough to force the filament all the way through, and so I would have some issues, and there was some problems that way. But I fixed it with a Bowden type fish gear, and I'll show you that in just a little bit. This fan over here is for a different purpose. So when you're printing, imagine when you're printing, you print layer by layer, right? So you print one layer and another layer. If you've got a piece that is not touching the print bed, how do you keep that from spitting out plastic and not just sitting in midair? You can't. It's impossible. It has to come from the bed or from another part of itself. So 45-degree angles are totally fine to print, because what it does is it prints. If you imagine my fingers are the layers of each print, and they go out this way, right? But there's nothing right here. Every layer can go slightly on the edge and slightly on the edge. And so 45-degree angles are perfectly fine. But if you start to get even further, what you get is this issue where you're printing in midair and it's not really touching any of it doesn't have enough structure. So the answer to that is to kind of combine things. You have to know your printer a little bit. One is a thing called bridging. And bridging, what it basically does is it cools the filament as it comes out of the nozzle, and that's what this fan is for. I don't have it on right now, but there's another 3D printed piece that comes off of this fan and points directly at the bottom of the nozzle. So it cools the print so that as it's layering it hardens quickly. It's not instantly, and so you still get problems, but what it's designed to do is if it's barely touching, it kind of melts to it and then it cools. So you can actually print almost really good bridges. And that's important too, because when you do top layers, you're not printing a solid piece, because a lot of times that's a waste of plastic. You can see this one here is printed. I'm using hexagon, so honeycombs, but I have it at 40% infill, which means it's 40% of this is filled in with this hexagon structure. It's very, very strong. I don't necessarily need it strong. This is a plant holder. I could print it with 10% and it would have been totally fine. One of the problems I've seen though is that when I'm printing the top layers of this, if it's a big circle versus a tiny little circles, that bridging doesn't work as well, and so it doesn't print it as smooth on the top layer. Even though you're printing a few top layers, you start to see this bubbly effect where there's no infill and where there's the lines of the infill. So I didn't want that with this, so I printed it pretty small, which is one reason why it's taking 3 days to print, because there's tons of infill and it's at a really high resolution. Okay, so that's about the fan and cooling, and you can kind of see right there. There we go. You can see the infill, and this is a honeycomb type of infill. But you can do lines, you can do triangles, you can do whatever you want. There's a few different settings depending on the structure that you want and how you want it structured. When you're printing flexible material, let me show you another material. This is called Fiberflex 40D, and it basically is like a rubber band, but it's not as stretchy as a rubber band. My printer has printed successfully with this. Just I didn't do anything to it. It worked. The only problem is it started to the because it's so flexible and like rubbery, it'll get jammed up in the gear. So you need to make sure to know that where that gear is where it's being forced from the gear to the nozzle, it has to be a very, very solid piece so that it won't get jammed up anytime, because it is flexible. But you can basically print rubber items, and they can be squishy and flexible, and they're awesome. There are certain nozzles that print a lot better than others when it comes to that. But they're expensive. The nozzle itself is like $200, and you can do tricks and stuff that will make it work. But that's basically it. And so this is the Raspberry Pi. This is the device that is controlling everything. That this has the website on it that I use to interface, that I connect to and I upload the files and I control the printer. This right here is a completely separate device. You can buy a Raspberry Pi for like $35. I've printed a case for it. It has an on-off button, so if it fails or has a problem, I can just push on off and restart it. And it's super easy. You just get an SD card, a little micro SD card, put it in your computer. You write an image to it that you just download off the internet from Octopi website. Stick it in there, and it's done. And you now have this ability to control your 3D printer that way. This is basically the computer that I would have used to connect my device to control it. So there's two ways to control a 3D printer. One is if it has an interface and you put your SD card in the 3D printer, and the 3D printer then you use to control directly on the 3D printer. That's like self-contained. The other way is to connect via USB to a computer, and then use the program on a computer to print and control the 3D printer. That's essentially what this Octopi is doing. It just takes over that role, and it has a web interface that I can access from a web browser and then control it that way. So same idea, just different use case. But this has been very reliable. Updates. There's a very big community on keeping these things working and secure and that kind of stuff. So that's super helpful. So that is the Octopi. The next thing that so I have a light also on the Octopi, and I'm using a Wemo that controls a light so that I can turn it on and off, because it's in my garage. I want to see my print sometimes with the camera that's mounted to look at it. It's just a super cheap Microsoft camera, and I've printed some stuff to hold my tools. Those tools are very useful. I'll talk about those in just a second once we finish this video. This right here is my the old 3D printer that I created out of a computer. This is the power supply. I've got this is a Bowden extruder, so you can see here that the nozzle is down here and it's not connected yet, but there's this Teflon pipe that will go into these nozzles, and you can see there's two nozzles on this one. I'm upgrading this. It's going to be a dual color or dual filament printer. I can print with two different colors or two different types of material, and that becomes a whole nother ball game in 3D printing. You can have one print that has multiple colors and parts, and it's really, really cool. Anyway, so I'm in the works of still modifying this and getting this back up and running. But if we look at the gear here, so this is what's called a fish gear, a fishbone gear, and it has high torque, helps out a ton in your printing, and that's what forces this filament all the way through. One of the nice things about a Bowden extruder is that the weight of this motor is not on the actual nozzle, so you can actually speed up your print a lot more. And what happens is when in physics, when you're printing something at a high speed, it's going back and forth. You get a lot of vibrations. The less weight you have on that nozzle, the faster you can stop and start and go the other direction. And that's what happens with a 3D printer, is it's often going back and forth a lot on a lot of its on its prints. And when you start to have that over time, you're going to get a harder. It starts to wear on your on the bands that control the back and forth motion, and it's harder to keep a very specific and precise control on that print. And so taking this weight and putting it out elsewhere from the nozzle actually helps out. But then you also have this line of an issue where you've got all this 3D filament that has to be forced all the way, and so there's this almost a delay in the nozzle coming out. So your printer has to kind of compensate for that, and there's ways to do that. There's tutorials on that kind of stuff. But that is the fishbone, and then here's the printer or the nozzle. You can see it's a lot less contained. It's a lot less heavy, but it does have two nozzles, and so that is going to be exciting for me to get up and running. Just a bunch of dirty parts right now, and there's the 3D print. So you can see it's layering, putting a layer of filament out every single time it goes around. So that's it. I'm just going to try to see if it doesn't focus there. There we go. And now you can see kind of the resolution that it was printing at. It's a high resolution. It looked like there was a little bit of an issue right here when I was printing this particular thing. All right. So with all that said, let's take a look at some of the tools that I use to print. This is a very useful tool. This is a spatula. I don't flip pancakes with it, but it's a much harder metal piece and thicker. I used to use this one, and it was sufficient until I had a really a difficult print to get off of the board, because it's supposed to stick on the board, stick on that hot bed is what you call it, a hot plate. And it just starts to bend these over time because they're so thin. This particular one is a lot stronger. It also has, it's almost a knife on the end of it that it's kind of sharpened off right there, so it's really thin. But this is my tool of choice when I'm pulling things off the bed. There's also these type of tools. I don't really use this as much. It still bends and it's flimsy, but I've used it, I guess, a little bit. A pair of needle nose pliers are an essential, because when that filament gets stuck in the nozzle and the filament breaks, you'll notice that if you're printing, it's kind of a pain to just always take the filament off. The filament will dry out and it starts to get a little bit brittle, and so if you're letting it sit there, because it's already formed in kind of a spool, it has a natural curve to it. When you let it sit there after it's been pulled out of its curve and it's sticking in the nozzle, if it's dried out, it'll actually snap. And then you have to reload the nozzle, and then it's kind of a pain, and sometimes it can snap really close to the nozzle, which means this is helpful to get in there and pull it out, or to push it back in, or whatever it might be. And so I have this right here, and I don't know if you can see this, if I go real close. I go really close to the camera here. Yeah, it might be too close. Oh well, it's not showing it, but this is a star screwdriver. It's a star, not just your normal. And it's small enough that if my filament goes into the nozzle too much, I can just stick this in here and push it down a little bit more, and then that way I can push more filament into it. That's happened often, and sometimes it's really helpful to kind of just clean it a little bit, clean it out, the top of the nozzle where the filament goes in to the hotbed, or that little hot box. So you take the gear off, and then you just put you push it in that way and make it work. I can have another whole new tutorial on this kind of stuff later, another time, on actual maintaining your printer. So I wanted to just also cover, I think that's about it. Oh, one of the most important things. So if we go back and look at some of the prints, I'll pull up this print. So this right here is a picture of, and let me zoom in a little bit here. This is the print. That's this one right here, this guy right here. And let me just show you the screen. All right, right here. So that's this right here when it was printing. The so what I was gonna say is, so how do you get this? How do you get these prints to stick? A lot of times you see people with glass plates. There's this Gorilla Glass that you can buy, and they're really cheap. Glass is really good to print on, but it in my setup, it's hard to just keep it stiff and still. You can clean it really easy. You can use a razor blade to clean it off. I am using just directly on the metal surface of the print bed. You can scrape it and make little indents in it, which means your print will show those indents if you're not careful. So, but a lot of people will use tape, like painter's tape or green tape, blue tape, green tape. That sticks to the filament really well. But then you end up using all of this tape, and it becomes kind of an issue. And I didn't like it because you have to keep putting more tape out, lines of tape. So I have found that Aquanet hairspray is the cheapest and the best thing that you can use to have your prints stick to the board, and you can actually spray that on the glass as well. What happens is it just dries pretty quick, and it becomes kind of a sticky substance, and you don't put much on, but once you do it, it will keep your print from warping up most of the time. And PLA, it won't warp. It can warp, but it doesn't warp if you're using if you use Aquanet on your board of where it's going to print. So that is it. I wanted to just give you that detail and give you that information. I will probably do another one of these in the future to get more information to you on 3D printing and what it can do and how it can be helpful. The other thing that I wanted to show you is not only the printer itself, but the Thingiverse.com. There's a couple of websites. That's not it. There we go. Thingiverse.com. So you can search a huge repository of things that you can download and print. And these are just, you can print them for personal use. It's not, there is a license, so you can't legally print them and sell them without the okay of the designer. But a lot of people have spent a lot of time designing all sorts of things in here. It's kind of an amazing website. I have myself created parts and put them up here. One of the things that I had trouble with was the screens, the bug screen on the outside of a window that is on a house. Those little attachments that hold the window in, they degrade over time in really hot environments. And so I was able to 3D print replacements for those in the color that I wanted and the size that I wanted. It was really cool, and I actually used them on my house. So it's kind of an amazing thing that can solve problems, because buying those was $10 but for me to print them, it was like pennies. So that's the kind of stuff I want to help you, that it can solve the problem that you might have, or it helps you figure out things that or abilities to do things that you never knew you could do in the first place. So appreciate you watching. Share this with your friends. This will be uploaded on YouTube as well, and you'll be able to take a look and watch this over and over. for information. Send me any questions you have, and I will answer them as needed. I'm also on Twitter. If you have any questions, ping me on Twitter, and I can print stuff for you all the time if you want. Thank you guys. Have a good one. Bye.